So we need to go a little further with solving and using different identities. There's so many different ways we can make these problems, but there's certain themes that kind of keep coming through. One of them is you have to be able to handle inverse trig, and we often nest them like this. So I'd like you to give this one a try without me, and then I'm going to solve it for you. If you're completely stuck, then you can keep watching here, but you really ought to give this one a try. It'll stick better if you try it first. All right, I'm assuming you have given it a try, and I would have started, of course, on the inside, and I would have rewritten this and said tangent of some angle is 1 over x. That's to remind me that every inverse like that is asking you to find an angle. Next, I would have figured out that there's a variable in it, so that tells me I can't just randomly pick a quadrant. I have to do this in the first quadrant. It'll make your life a lot easier if you do. So tangent is TOA, opposite over adjacent, so 1 over x. And this last side has to be square root of x squared and 1 squared, and since it's the longest side, you add them. All right, so x squared plus 1, square root of x squared plus 1. All right, then, once you've drawn the triangle and labeled the sides, you're pretty much done. The last little step is just to do the cosine of the central angle, or sometimes we call it the reference angle. And cosine is adjacent over hypotenuse, and so this is x over square root of x squared plus 1. All right, next one. On this one, we're trying to solve cosine squared of theta is equal to 1. And the most common mistake here is to think it's a little too easy and just square root both sides. So cosine of theta is equal to square root of 1 is 1. Oh, cool. And then you go off and you solve it, and you're wrong. Why? Because when you square root a variable, you get the absolute value of that variable. And that means that there's two equations to solve. Cosine of theta is equal to 1, and cosine of theta is equal to negative 1. All right, so from there, I'd like you to solve this puppy and get multiple answers anyway. There's either 3 or there's 4. Notice it does say here between 0 and 2 pi, so we're not going to add that plus 2 pi k thing. All right, assuming you've done it already, and then you've got cosine is positive, that's going to mean we're either here or here. And let's see, this one is cosine is adjacent over hypotenuse. Oh, interesting. This is one where I can't make a cosine where the adjacent and the hypotenuse sides are equal unless I'm on a quadrantal. So I'm going to need to just label my little quadrantal spots and do it that way. So this spot right here is at 1, 0, and this is at 0, 1, and this is at negative 1, 0, and this is at down here is at 0, negative 1. And cosine is all about the x. And so this is really saying, where is the x value? 1. And which of these has an x value of 1? Only one of them. And that's that, which is at 0. And if I'm deciding whether to call it 0 or 2 pi, I look up in here and I say, it's got a bracket on the 0, so it's saying it can be 0. It's got a parenthesis on the 2 pi, it's saying it can't be 2 pi. So I must pick the answer of 0. So 0 is my first answer. So theta equals 0. I'm going to write it down here. Then I'm going to make another one. For this one, where is cosine negative 1? Same idea. I just now have to also pick where x is negative 1, and there's only one spot. And oh my gosh, I was wrong. There isn't 3 or 4 answers. There's just 2 answers, because where is cosine negative 1? It's where x is negative 1, and there's only one spot for that. Where is x negative 1? Right here at pi. And so my 2 answers are 0 and pi. You know, I was expecting that one of these would have 2 answers and the other one would have 1, but they both just have 1 answer. All right. Next up, if I'm going to solve this one, first off, I better recognize that sine to the third is kind of a hint that we're going to have a sine squared times a sine. All right? And this can be baffling. You could be thinking, wait a minute, is sine squared the one that's on the sheet? Well, there is a sine squared on the sheet. But since we've got it all in terms of sine right now, I don't want to like swap out sine and put in something else like cosine. That's just going to make it worse. It's better that we have only sines involved right now. So I'm just going to subtract sine of theta from both sides. So now I'm going to have sine to the third of theta minus sine of theta is equal to, well, once I subtracted that sine from both sides, I had 0 left on that side. So now I'm going to, if I can factor it, I should. Anytime you have a really tough one, think about that option. So sine of theta comes out to the front, and then I have sine squared of theta minus 1. And I hope a few of you caught that. So, Mr. Server, you say if you can factor it, you should. Then I'm going to factor it again. Sine theta plus 1, sine theta minus 1. Now, this one is going to have 3 answers. Either this part equals 0, so I'm going to write a little equation for that. Sine theta equals 0. Or this part's going to equal 0. Sine theta plus 1 has to equal 0, so sine theta equals negative 1. Or this part equals 0. Sine theta equals, or minus 1 equals 0, so sine theta equals 1. So I have 3 separate answers. In fact, I have even more than that. All right, I think, well, I might have 3 answers. We'll see, one at a time. So where is sine 0? It's like asking where is y 0? And y is 0 at this spot and this spot. So it seems like I have 2 answers. I'm just going to double check by saying that's 1 comma 0. And this is negative 1 comma 0. And isn't y 0 at both spots? Yep. So 0 and pi are 2 answers for that one. Looks like there will be lots of answers. Now I'm going to try this one. So where is sine negative 1? Well, that's like saying where is y negative 1? And that would be down here at 0 comma negative 1. So that spot, which is, let me think, 3 pi over 2. So I have my first answer was 0 and pi. My second answer is 3 pi over 2. And now I got to see where is y 1. So if I look back at my original, y would be 1 up here at 0 comma 1. And so only one spot, and that is pi over 2. So I have a clean sweep. I've got 0 and pi over 2 and pi and 3 pi over 2. All of these spots, here, here, and here. All right, so there were 4 answers for that one. And it all started with noticing that I could factor it after I moved something to the other side, set it equal to 0. All right, now the toughest one of them all. So on this one, you're going to need to do a substitution off the sheet. So I'm going to let you think, look at your sheet, and seriously, you need to try these yourself. Otherwise, just watching me do them, you're going to remember 10% of it. If you like scores of 10%, you're going to love how you will crash this test. So go try it by looking at the sheet. Come back if you get stuck. All right, so hopefully you looked up that cosine of 2 theta could be actually 3 different things. But I'm going to pick 1 minus 2 sine squared of theta. Why did I pick that? How was I supposed to know I should pick that? Because that way the whole equation is just sine in it. And getting it down to just one function is key. Okay, so that's why I picked this off the identity sheet to solve this with. Now I'm going to multiply it out, and I get negative 2 plus 4 sine squared theta. That was me just distributing out this negative 2 here, is equal to 12 sine theta, and I should have theta there. I apologize. That's not an x, that's a theta, plus 14. Now I'm going to subtract 12 sine theta from both sides, and forgive me, I'm going to do a double step. I'm going to subtract 14 also from both sides. Minus 12 sine theta minus 14. And now the right side has become 0. Why do you think I'm doing that? Because I'm going to set it up and see if I can factor it. So now I have 4 sine squared theta minus 12 sine theta minus, and now I'm putting the negative 14 and the negative 2 together and making negative 16. And now I'm going to factor out that 4, because if you can factor it, you should. Sine squared theta minus 3 sine theta minus 4. And now, not coincidentally, we made it so that you could factor it. Sine theta, and then I'm going to say, let me think, minus 4 and plus 1. Double checking that that worked quick. Mainly, you make sure that the firsts would make sine squared, yep, and the lasts would make negative 4, yep. And then the outside and the inside here, they make negative 4, and positive 1 makes negative 3 sine theta. Yay, this worked. Okay, so now I'm going to solve this part. A lot of people are like, how do I make that 0? You can't. 4 is not 0, so that does not give you a solution. This part should be set equal to 0. Sine theta minus 4 equals 0. Sine theta equals 4. And then right there you should be able to go, wait a minute. Sine, the highest it ever goes is 1. There's no way to make sine be 4. So there's no solution on this part. Sometimes people call it DNE, does not exist. All right. So then this last one, sine theta plus 1 equals 0. And I know you know that's going to mean when I subtract 1 from both sides, it's sine theta equals negative 1. And now that's one of those ones where I got to figure out where is y negative 1. And the only place where y is negative 1 is down there. And that's at 3 pi over 2. And that's my answer. That's the only answer? Yes. That long, difficult question has just one answer. Now, wait a minute. Does this one say... Oh, it says from 0 to 2 pi. That makes me think on one of the other ones, I think it was the prior screen, I had said to find all the solutions. I should have put a plus 2 pi k after each solution. And I apologize for forgetting that until just now. But for those of you that thought you caught me, you did catch me, but I just remembered because it said to find all the solutions on one of the prior slides, you should have put plus 2 pi k. All right, and that is it. I'm suggesting that you do some practice problems. There's a worksheet, and I am assigning all of them, but we have a really good digital like video key of it to explain exactly how to do them all. And there's also a regular key. So do them, check them. Either way is fine with me. And that's your homework for tonight. Have a great day.